Distribution network operators, DNOs for short, are responsible for supplying us with electricity safely and reliably from the substation. They are particularly interested in peak demand, which is when the network is put under the most stress, typically in the evening. These stresses are expected to increase as electricity consumption continues to evolve. Solar panels and charging electric vehicles add current to the network, causing stresses upon the infrastructure which were not originally anticipated. An obvious solution is adding more copper wire to carry this current. This would come at a cost, which would undoubtedly increase our electricity bills. So what can be done? Households are being fitted with smart meters, which measure the electricity consumption every 30 minutes. This opens the door to big data, which informs, for each household, the precise times of demand as it occurs. If DNOs could predict upcoming peaks and troughs, they could use batteries, which charge during times of low use and discharge during times of high use. Predicting peaks and troughs requires probabilistic forecasts. Applying these predictions over the whole network using its smart meter data, batteries can be optimally placed to lessen peak demand stresses. Smart meter data is a great tool for the DNO. However, ownership of smart meter data is between the customer and the supplier, making many customers' data inaccessible to the DNO. To use this limited resource effectively, customers without smart meter data are buddied to customers with smart meter data. This creates a half-hourly profile for a customer based on their quarterly meter reading and council tax band. The buddying process is an optimization problem solved using a genetic algorithm. Forecasting over the long term, DNOs need to predict how solar panels, electric vehicles, and heat pumps will be deployed along the network. For example, an electric vehicle charging far from the substation is more troublesome than one closer to the substation. Furthermore, there is a keeping up with the Joneses effect, where a customer is more likely to get low-carbon technology if their neighbour does. To predict the placement of low-carbon technologies, with clustering, an agent-based model is used. In conclusion, as knowledge is gained, the models keep growing in complexity. Forecasts are being adapted to account for the influence of weather, local businesses, and the continual rise of electrical products.